sequence and series are one of the most important topics that a student is likely to come across, be it any class you are dying with. In SS1, 2, or 3, we are going to come across such a topic as this. So on that note, we are going to be talking about sequence today. Sequence. We're going to be focusing on sequence. And the first line of action is to define what a sequence is. So the question is, what is a sequence? So a sequence can simply be defined as a set of numbers that follows a regular pattern or a defined pattern. And that's a layman definition actually. I think it's better for us to define that way so we can from there get ourselves used to it before we go to a more acceptable definition. So like I said, a sequence can be defined as a set of numbers that follow a definite or a defined pattern. But in a more acceptable way, we can say a sequence is a set of numbers that is defined by a function or that is generated by a rule. There's a sequence, a set of numbers that is generated by a rule. So another school of thoughts define a sequence to be a special function. So any function that bets a set of numbers, we call such a sequence. Do you understand what I'm trying to say? So for instance, it is believed that if I have a number, say 2, say 4, say 6, 8, 10, which is popularly known as even number, there is a particular function that bets this sequence. Do you understand? So that could be anything, but basically I know the most thing you can talk about is 2n. Maybe the sequence that bets this function is 2n, though n is what? N is a natural number. What does that mean? When I say n is a natural number, meaning that n can be 1, n can be 2, 3, 4, and normal counting numbers. That's what we refer to as natural number. So if I say that my function f of n equals to 2n, and my n is an element of natural number, like I explained earlier, n can be 1, n can be 2, n can be 3, and so on. N can be whole number, not decimal or any other number, it's a whole number. If I impute, if I put 1 into this place now, such that my n is now equals to 1, this can become 2 in brackets 1, then this one will become 2 times 1, and that's 2. When I fix a 2 into this bracket, it's become 2 in brackets 2, which means 2 times 2, and that's 4. When I fix 3 into this bracket, meaning that when n is now 3, it will become 2 times 3, which is 6. If you check it out, it is just generating this mark on the board, 2, 4, 6. If I put 4, I'm going to have it like that. So something like that is called a sequence. And that's because it is generated by a rule. I want the rule that generates this sequence now. The rule is what? 2n. You can also call it the generator. It's the rule that generates those numbers. So that's the sequence. On this note, I'm going to explain a little more about sequence and how it can generate numbers. So take one or two examples before we now talk about the types of sequence. So let's take some examples on a sequence. So imagine that you are asked to write out the first 5 terms of the following sequence. Okay, number 1. Imagine we have, say, f of x is equals to x squared plus 1. You can also imagine we say that zn equals n over 2. So also imagine that we say that p of w is equals to 1 minus w all over w. Now look at this, all these are term sequence. So all these are term sequence. So I will solve the homework for you, then I will leave you to pause the video, while you're trying with 2. After you have tried it, then you can now try to verify my answer while I solve that. So let's check. Look at number 1 question. We have f of x to be equals to x squared plus 1. And we just said, write out the first 5 terms of the following sequence. Between, I need to let you know that the sequence is denoted by something like this. A curly bracket, x subscript n, as case may be, maybe n starting from 1 all the way down to, as case may be, or let me say x subscript I, then I starting from 1 all the way down to n, a defined sequence. So this is how we denote a sequence with a curly bracket, and this simply means a sequence. Some people can write it as this, just say in curly bracket x subscript n. This is a denotation for sequence. So that being said, let's quickly solve for the first 5 terms. I mean the first, the second, the third, the fourth, and the fifth term of this sequence. So I say when x 1, 2, 3, 4, then 5. Because it's the first 5 terms. You have told us the second, the fifth, and the 10th. It means you just be focused on the second term, the fifth term, and the 10th term, depending on the request of the examiner. So that I will say when what? When x is 1, then I will have f1 equals 1 raised to the power 2 plus 1. It means wherever I see x, I will be replacing it with 1. So that being said, 1 squared means 1 times 1, and that is 1 plus 1, and that is 2. So I will say again, when x is 2, so I have f2 equals 2 raised to the power of 2 plus 1. 2 raised to the power 2 means 2 times 2, which is what? Which is 4. Then I will say plus 1, and that is equals to 5. Then I will say when x is equals to 3, meaning f, where I say x, I put 3, and that is 3 raised to the power 2 plus 1, and 3 raised to the power 2 is 3 times 3, and that is 9. So I will say 9 plus 1, and that is equals to 10. Then I will weigh when x is equals to 4. So I will say f4 is equals to 4 squared plus 1, and that is 16 plus 1, and that is equals to 17. Then when x is equals to 5, then I will have f5 to be equals to 5 raised to the power 2 plus 1. 5 raised to the power 2 is simply 5 times 5, and that is 25. 25 plus 1, and that is what? 26. So on that note, I will now say that my sequence is now start from 2, 5, 10, 17, 26. It could go on and on. We only decided to stop at the 5th time. So we now write the generator back. What is the generator? X squared plus 1. Meaning that this guy, this particular function, is the one that generated all of the sequence. So in case you want more of it, use this one to use the next time. So this is how I write the sequence. So I will point you to pause the video and kindly solve the other 2 questions. So afterwards, you are going to check up my answers. Okay. I believe you have attended it and you have your answers already. I will try solving number 2, then I'll just write out the answer of number 3. You cross-check with yours and see if it is the same answer you got. And don't forget, not in mathematics, you are not just focusing on the answer. We are very, very keen on the process you followed to get your answer. So now let's try number 2 together, compared to what I've solved in the book. Zn, I tried to be flexible by using different kind of symbols so that you not think that it is limited to this kind of denotation. It could be any of these stuff. Just understand the concept behind it. Zn equals n over 2. And don't forget the first 5 times. So when n is 1, either 2, 3, 4, or 5. So I go and say when n is 1, meaning whenever I see n here, I put 1. And that is equals to 1 over 2 because n is simply 1, and that is 4. Then I go again and say when n is 2, I will say z in bracket 2 is equals to 2 over 2, and that is 2 here 1, 2 here 1, and that is 1. Then I go again and say when n equals to 3. So what will I have? N is equal to 3, and we have z3 equals to 3 over 2. That's how simple can be solved. Then I go again and say when n equals to 4. So it becomes z4 equals to 4 over 2, and that is equals to 2. I go again and say when n equals to 5. So I'm saying z5 is equals to 5 over 2. That's equals to 5 over 2. Then when I go again like I did in the first example, and say x, it can be written as this in this form. We could say zn is what is now equals to what? Equals to 1 over 2, comma 1, comma 3 over 2, comma 2, comma 5 over 2, comma dot dot dot, comma the generator, and you have solved it already. So if you have something like this in your note, you are very correct. And if you do not think that, just go through it again and see what you have done. Then we'll check number 3. Again, 3. We are doing the same thing. Actually, that is one beautiful thing about mathematics. You need not to cram anything. Just follow the same step that other examples have followed, and you're going to have the same answer. Our confidence is our process. We are not cramming anything. We are just trying to follow the process as it has been highlighted in the earlier example. So let's see the first 5 terms. When w equals to 1, 2, 3, 4, and 5, because I have w here. The first example I had x. The second one I had a. Now it's w. So that you can just see that there can be flexibility. It's not you just try to get used to f of x alone. The function is not limited to f of x. Those are just double variables. So I try to represent something to those variables. So I'll say when w equals to 1, so I have p1 because w is now 1, equals 1 minus 1 over 1. W is here, so I'll put 1 here, because w is now 1, and that's equals to 0 over 1. If 0 over 1 is simply, I write again, when w equals to 2, so I have p2 equals to 1 minus 2 over 2. 1 minus 2 is minus 1 over 2, and that's my answer. So I will go again and say, when w, equals to, I have pw equals to 1 minus, when w equals to 3. 1 minus 3 over 3 equals minus 2 over 3. Then I write again, when w equals to 4, I have pw equals to 1 minus 4 over 4, and that's minus 3 over 4. Then I write again, when w equals to 5. So I say pw equals to 1 minus 5 over 5, and that's minus 4 over 5. If you check also, you see that we do not make anything complicated. All you just need to do is follow the process as it analyzed. Then you go to present your answers in a more formidable way. Your sequence PW is then equals to 0, minus 1 over 2, minus 2 over 3, minus 3 over 4, minus 4 over 5, dot dot dot, and derivative is 1 minus w over what? Over w. So that will be our final answer. I'm going to give a quiz for you to try during your real time. Afterwards, I'm going to tell you about the types of sequence that we have in the next class. Okay, so I'm going to be giving some quiz, like I said, so that you can try for yourself. Simple quiz, simple mathematics quiz. Write out the second, the fifth, and ninth terms of the following sequence. Now, what you're going to be doing here, or like what we initially, where we found the first, second, third, fourth, and fifth, you just define the second, the fifth, and the ninth term. Do you get it? So, number 1, this time we can say wx is equals to what? 1 minus x. Then with 2, we can have f of p equals to p raised to power 3 plus 1. Then number 3, we can have Zn equals to n plus 1 over n. And lastly, we can just have k C or C. So you can try this already, and when you are done, you can drop your answers in the comment section. So I would like to see them. So thank you for being a part of today's class. Do not forget to subscribe and turn on your notification bell so you can get the videos when I will post them.